These are our notes for 5.4. You know what to do. So one thing that I want to make sure that we are very clear on is the difference between a food chain and a food web. So a food chain is actually just one single pathway in which the energy and matter flow. So looking at going from a producer to a primary consumer to a secondary consumer to a tertiary consumer, and then eventually maybe even an apex predator. So you have the corn that's eaten by the locust. The locust is then eaten by the lizard, and then the snake eats the lizard. So that would be one direct path that the energy and matter flow, starting always down at the bottom with your producers. Now, comparatively, the food web is all of the food chains in a single ecosystem. So you're looking at this interdependence of all of these organisms and how they rely on one another. And basically, you can follow the arrows to see who eats whom. So the black arrows are indicating, like, for example, if you look at this instance, that we have here this mouse eats the grass. So that's why the direction goes there. So kind of think about it, what goes into whose mouth. So the grass goes into this mouse's mouth. And then what goes into this fox's mouth is the mouse. So that's why the arrows are drawn in this direction. Now, the one thing that I want you to note is the arrows pointing downward. We talked about how everything in an ecosystem, you can't create or destroy matter, actually. So when things die, they need to be returned to the earth, and that matter will be broken down either by decomposers or then furthermore by the detritivores that live in that ecosystem. So all living things will always have arrows that return back to the earth. So once again, a food chain is just a single pathway, and the food web is all of the food chains in an ecosystem. So when we look at this, though, the important thing to realize is that where all of the energy either originates from and how it is used as you move up the energy pyramid. So each step in a food chain or a food web actually has a certain level of energy that is used and being able to transferred. All of the energy, though, since we talk about how the producers are the bottom of our energy pyramid, all the energy in an ecosystem can be traced back to the sun, since the primary producers are going to use photosynthesis to create their energy. The one thing that I do want you to note, though, if you look at the percentages over here, I know it's kind of hard because it's in red. So the primary producers have 100% of the energy that they are able to make because they do it directly from the sun. Every time I go up a level, there is only 10% of that energy can be converted into biomass, which is actual energy that's in a living thing that can be transferred from one organism to the next. So notice how it goes 100% to 10%. And then it goes from that level to the next level, it's 1%. And then from that level up, it's 1/10%. And then from that, it's 1/100%. So every time you go up the food pyramid, if you will, here, but also thinking about this as like a food chain, there's going to be 10% of that energy that's only translatable up to that next level. What I want you to realize in terms of that is because of the fact that the producers make so much energy from the sun, primary consumers actually don't need to eat as much as organisms that are either tertiary level consumers or apex predators. Because by the time that the food an apex predator eats, most of the energy that has been produced by the primary producers has been used up by that organism. So that's actually why apex predators need to eat a lot more than you will find that primary consumers do. So the energy pyramid is actually divided into 5 different levels. So the first level, like I mentioned, is the primary producers, where all the energy can be traced back to the sun. The second level would be like your herbivores that eat only the plants, right? So they eat only the primary producers. So we're looking at, maybe let's use an example of a deer in this ecosystem. Then level 3 would be the carnivores and the omnivores that eat the primary consumers. So in addition to our primary consumer being a deer, you might also have a mouse and things like that. So the level 3, the secondary consumers may more or less be like the snake that might eat that mouse too. Now, level 4 is going to be the carnivores and the omnivores that eat the secondary consumers. So maybe you have another organism that will come and eat the snake. And then finally, you have your apex predators, which are the ones that have no natural predators whatsoever that will come and eat the third level consumer. Now, remember, all of these organisms, when they die, all of that energy, and even their waste as well, is broken down by the decomposers. And some of you may be wondering, well, where does all that energy go? Well, a lot of that energy from one level to the next, the reason why only 10% can be converted as biomass is because a lot of the energy is lost in heat. So if you think about like the mouse that's eating the primary producer, which is the grass in this example, the mouse uses a lot of that energy to run, to keep itself warm, and especially at nighttime and things like that, and to use it up. So it uses up a lot of the energy that it eats. And when the I don't know, the snake comes and eats the mouse, there's only that much. There's only 10% of that energy that's able to be transferred to the snake. So for this slide, I would make sure not only understanding what trophic levels are, which is the different levels of energy that can be transferred from within the food chain, I think I would also make sure that you kind of draw the diagram that I have included over there. So pause the video now if you need to do so. Now, this is just a further explanation, and you can either add these numbers to your notes so you can kind of understand that 10% breakdown from each level as you go up the trophic level diagram here, and or you can just redraw it and add this information, whatever you feel is going to be best for you to understand this. But the one thing that I do want you to note here is that if we were to quantify this, so let's actually say that the primary producers, remember, all energy can be traced back to that big yellow thing in the sky, the sun. Let's say that the primary producers, so the grasses and the bushes and the trees in this ecosystem, all produce 20,000 kilocalories per square meter per year. So basically, this is just saying how much energy is stored in a certain area for the year that's elapsed. So 20,000 kilocalories is the amount of energy that's there. Now, one of these primary consumers is going to eat the grasses here. So let's just say we've got this caterpillar here. This caterpillar is going to eat the grass. Now, there is only a 10% energy that can be transferred to the caterpillar in forms of biomass, and that's going to be 2,000 kilocalories per meter squared per year. So once again, do you notice that 10%? The easiest way to figure that out is you just move the decimal place one spot to the left, and that's how you'll get 10%, right? So the caterpillar uses up the other 18,000 kilocalories by living, moving, metamorphosizing, all that stuff. And what is saved and stored up inside of its body, when the toad here eats the caterpillar, there's only 10% of that can be transferred to the frog. So once again, if you move the decimal place to the one spot, there's only 200 kilocalories that these organisms are going to give to the secondary consumers. So they will use that energy up to, they'll store their biomass. And then when you have something like this snake eats the frog, because the frog has used up 180 kilocalories per meter squared per year to live and do whatnot, when the snake eats it, it actually only gets 20 kilocalories from that frog. Now, the snake, if it's eaten by this red-tailed hawk, it looks like, I don't know, I'm sure some ornithologist out there is going to correct me, but this is eaten by this large bird of prey. This is our apex predator. Nothing naturally is known to prey on this. So the information that's actually interesting, though, if you look at this 10% of that biomass from that snake, when the bird eats it, there's only 2 kilocalories of biomass translatable energy that the bird will actually get from eating the snake. Now, once again, remember, lots of this energy is lost to heat. It's lost to heat. It's returned back to the atmosphere. And when they die, everything comes back to those decomposers. Now, the decomposers also release some heat back out into the energy, the ecosystem as well, too. So this is just a breakdown to quantify how the level of energy changes from each level in the trophic system. And we look at all of the energy being traced back to the sun, and the energy that's stored as the biomass or the usable energy that can be intaken from the organisms is indicated on the left here. So you can either, once again, add this information to your diagram, but the one thing you will need to know, once again, is there's a 10% reduction in the amount of biomass from one level to the next, going all the way up to the top. Lots of it's lost by heat. Everything returns back to the earth and is broken down further by decomposers and detritivores. This is the end of these notes. I apologize for the length, but I just really wanted to make sure you had a good, accurate description of how a trophic level diagram works.